This meeting is being recorded.
In problem 19 from chapter 5, we're given 5 pairs of compounds, and we're asked to identify whether they are enantiomers or diastereomers. So if you recall, if we know that we have isomers and they are non-superimposable mirror images of one another, we are looking at enantiomers. On the other hand, if we have isomers that are not superimposable, nor are they mirror images, then we would have diastereomers. So let's take a look at our first pair of compounds here, and we would assign a configuration to each of these chiral centers here. We would see that this would end up being an R configuration in this compound, and this configuration here would also be R. So if you're having trouble seeing that, go back and review the Kahn-Ingold Prelog rules of priority, because we would have our highest priority group would be here for this compound, and then 2, and then 3. So that's what makes this an R. And then we would see the same thing, 1, 2, right? And then 3 here, we would see what would appear to be S, but we know that our hydrogen's not on a dash, so we would invert it. So that's where we get our configuration for both of these. Then we would see in our second compound, we would do the same thing, determine our configurations. This would be S, and this would be S as well. So what we see are in the first compound, both chiral centers have R configuration, but the second compound, we see both have S. So these would then be mirror images of one another, but they are non-superimposable. So if you try to rotate on a 180-degree axis here, if we had our mirror images, we could not generate one compound that would be superimposable. So we would call these enantiomers. So we're going to do the same thing for the remainder of the pairs, but I'm going to do the configuration determination much quicker. So we're going to see here in this first compound of B, we will determine this to be an R configuration. And then down here, we would see this to be an S configuration. We just did this with the first compound in A, which was RR, but that was on a dash. So you can see how this would determine to be R and then S here, like so. And then in our second compound, this would be S, and this would also be S down here. So because our configurations are not going to show us mirror images of one another, we know that these are stereoisomers of some sort, but because they're non-superimposable, nor are they mirror images, we will call these diastereomers in this case. All right, so let's take a look at C. And again, we would determine configuration of our compound. So here we see R, here we see R as well. Then we have over here, we have R configuration on this carbon and S here. So once again, these would be diastereomers. Let's take a look at D. Now we have 3 configurations to assign. So we would find this to be R up top. This would be S in this first compound, and then this will be R as well down here. So we have R, S, R. And then let's take a look at what could be a mirror image. We have S here in this determination. Then we have S as well here, and R for our list. So we have RSS in the first compound, and then SSR going from top to bottom. we would need all three of our configurations to be opposites, but we see that these are not mirror images of each other, and we do not have a reflection of all of our chiral centers. So once again, we would see diastereomers. So our last pair here, we'll do the same thing. We will assign configuration and compare. And now we're back down to just two chiral centers. So we have R here. This would be determined to be S. Next we have R and this site and R as well here. So once again, these compounds are stereoisomers, but they would not be mirror images of one another. So we would find them to be diastereomers. So overall, out of our 5 groups, 4 were diastereomers and only 1 were found to be enantiomers.